Okay, with the test approaching, it might be a good time to do a review of Newton's laws of motion. Newton's first law is essentially about inertia, and that is that objects have a tendency to remain at rest or in motion. So anytime I give you an example in which you see an object remaining either at rest or continuing to move in the same speed and direction, that's going to be an example of the first law. Let's take a look at a couple quick examples. The tablecloth trick is a great example of Newton's first law. The idea is that when this person pulls the tablecloth this way, the objects on the table having inertia are going to remain where they are even as the tablecloth moves the other way. Another good example of the first law of motion would be, let's have a kid who stands up on the bus as the bus approaches the bus stop. The bus is in motion and so is the kid. So if the bus was to stop moving, unfortunately the kid continues to move forward. Perhaps that's happened to you. Another example of Newton's third law would be, say, a car going around a curve in the road. If you're in the car and you have something on the dashboard, as the car goes around the corner like this, the object wants to keep going straight. So if you're that person in the car, you feel yourself being shoved. You feel as though you're being shoved against the side of the car, but actually you're just going straight like this as the car goes around the corner. Newton's second law relates force, mass, and acceleration. Basically what it says is because mass causes inertia, that what we find is that more force is going to cause more acceleration, whereas more mass is going to cause less acceleration. Now, an example of that I always like to point out is the case of one person of normal proportions pushing a shopping cart, and then basically what happens there is we have a fairly small amount of force, so that's going to produce a fairly small amount of acceleration. On the other hand, if we have Sergeant Steroid with his big muscles, and he's going to push with his big pecs and rippling abs and his quads and his big powerful kneecaps, because he generates a much larger force, he's also going to produce a much larger acceleration. Another good example of Newton's second law would be one linking mass to acceleration. What we have is this car over here has a very low amount of mass in it. It has an empty bed, whereas the other one has a lot of dirt piled in it, giving it a much larger mass. So we find that is because this one has a small mass, that means it's going to have a large acceleration, and this one over here has a very large mass, which means it's going to have a proportionally smaller acceleration. Now, examples of Newton's second law would include things like why it is that it hurts more to kick a bowling ball than a soccer ball, or any time we're comparing mass to acceleration, that would be a good example of Newton's second law. And Newton's third law concerns how all forces basically operate in two directions, that there's always an equal force in opposite directions. Another way to think of it is that a force must exist between two objects, and each are either pulled or pushed in opposite directions with equal amounts of force. Remember, it doesn't mean there's equal and opposite reactions. It means that the force is equal in both directions, not necessarily what we can observe in terms of the way the object moves. So a great example of this would be a cannon. So if a cannon fires a cannonball, the cannonball comes out and moves forward. Well, the cannonball has a fairly small amount of mass, and it's going to have a fairly large velocity, whereas in this direction, whereas the cannon will be pushed backwards, and since it has a proportionally larger mass, it will have a smaller velocity. And what Isaac Newton realized is that these two equal each other. So he liked to think of it in terms of momentum. So momentum generated in one direction equals momentum generated in the opposite direction. So anytime we're looking at a case of things being pushed or pulled equally in opposite directions, we're dealing with Newton's third law.